This photo was taken by Apollo 15 at what is called the LSEP site or Station 5. Looks good enough. We can see the lander in the photograph. An astronaut was behind the lens and took this photograph. All seems well. But there is something very strange if we look closer. And we only see it when we look at another Apollo 15 photograph. Let's take a look at what we will call the second photograph. This photograph was taken at Station 9, called Hadley Roll location. That is 1.4 kilometers west from the lunar module, or 1.4 kilometers west of the location of the first photograph. Have a closer look. See if you can spot what is in both photographs. Do you see it? Maybe it will help if I put both photographs beside each other. Now take a look. Do you see it now? That's right. The backgrounds are identical. In fact, if we superimpose one over top of the other, they match completely. Not only that, but the lunar module is gone from one photograph. So even if they logged the same photo by mistake as different locations, then there would be no one to take the photo. Because there is no lunar module. This excludes any logging or simple photo tagging errors by NASA. Since the lunar module cannot be moved, it lands and then takes off from the same location. The evidence shows, without a shadow of a doubt, that the same backdrop was used. That is, a backdrop on a film stage. Again, let's look at both examples side by side. Do you see it now? They have just shifted around the foreground, one photograph with rocks in it, another with dust. But they used the same background. Now look at perspectives on Earth. We might not be engineers, but we all know about perspective. That is, we have looked at hills and mountains, and landscapes all our lives. So we have knowledge in this area, all of us do. So how can you have the exact same landscape in the far background, appear in a different location, that is 1.4 kilometers away? The fact is, you cannot.
A very good morning and welcome from the Mission Operation Complex of Telemetry Tracking and Command Network, an unit of Indian Space Research Organization ISRO located in Bangalore in the southern part of India. Now if you look at the overall sequence that has happened since the Chandrayaan 2 was inserted into the orbit, the Chandrayaan 2 spacecraft was eventually captured into an orbit around the moon, and later it performed almost 4 lunar bound maneuvers and lowered its orbit to almost 100 kilometers around the Earth.
Out of 1,000, out of 500, 400, 300, 200.
Missing a gear.
Cell ramp down.
Where?
Landing small negative. Engine out.
She's coming over.
Okay, we had a gear that was not out. Yeah, fire suppression. There you go.
The countdown is at minus 22 minutes, 2 seconds to go. After 22 minutes, you will be witnessing the powered descent of the Vikram lander module. As I just mentioned, the Vikram lander module is presently orbiting in an orbit of 30 kilometers peri-Lune, which is the lowest altitude from the surface of the moon. There is a need for us to reduce the velocity. It's something like braking, and quite eventually the job is being done now. Maybe it's around 450 meters per second and another 2 minutes plus to go. In fact, I think when we reach an altitude of almost the target for this particular rough braking phase is to attain an altitude of 7.4 kilometers, when the velocity should have touched almost 146. So maybe another nearly 2 minutes, maybe 1 minute to go. So we have finished the rough braking phase now, because the target for that was 7.4 kilometers and the velocity was nearly 140. So the Vikram lander has successfully completed the rough braking phase, and now we have entered the next phase of operation, which is the absolute navigation or attitude control phase, and this particular event is going to last for nearly 38 seconds, and the 4 throttleable engines are continuously on, and we see the velocity is something like 86 meter per second and roughly 4.43 kilometers away from the landing site.
10, 9, 8, 7, 6, 5, 4, 3, 2, 0.
We're going to stand down.
The velocity right now, if you look at the plot, we have the Vikram lander has a horizontal velocity of nearly 48 meters and vertical velocity of 60 meter per second. After the completion of the fine braking end, we will have the vertical descent operations where the spacecraft will be moved from nearly 400 to 700 kilometers down to the lunar surface. We're just waiting for the confirmation. The spacecraft, as we see on the screen, is showing the horizontal and vertical velocity of nearly 48 and 59 meter per second.
थोड़े से क्षण जहां पे हमें आंकड़ों की प्राप्ति के लिए इंतज़ार करना पड़ रहा है, जैसे ही आंकड़े प्राप्त होते हैं हम आप तक पहुंचाने की कोशिश करेंगे.
Confirm any signal from station.
Once we have the updates from the mission control room, we will come back to you. Looks like they are just looking at the flight data.
All subsystems empty. Orbiter operations are on.
In fact, at the end of the fine braking phase, the Vikram lander should have been at an altitude of almost nearly 400 meters. And if you look at the plots, we are seeing that it has most reached close to a kilometer from the landing site.
This is Mission Control Center. Vikram lander descent was as planned and the normal performance was observed up to an altitude of 2.1 kilometer. Subsequently, the communication from lander to ground station was lost. The data is being analyzed.